Algebra, we're looking at lesson 2 today, Transformers More Than Meets the Wise. Okay, name of the game today, if you look at the jumpstart, starts with these 3 words, without using technology. So for today, you can take that graphing calculator, you can put it just right to the side. We are not going to be using that today. We're going to be using our brain and our logic and what we know about how these numbers affect the graph. Okay, would you please start with the jumpstart? Go ahead and pause the video. I want you to match these graphs to their function based on what we talked about yesterday. So just kind of a chance to review that real quick, and just be careful. There is one extra graph that you don't need. All right, so let's check it out. So this should be a situation where A should be going with 2, right? It's been shifted 3 down. That's what we see. In answer B should go with graph number 3. It has been made very narrow, right? A vertical stretch just right there. C should go with 4. We've got a shift over here of going 3 to the right. And then for D, this is going to be the one that's really, really wide, and that's going to go with graph number 5. And so that's going to be this one that's a little bit wider out, right? Instead of going over 1, up 1, over 2, up 4, we've got a wide kind of out there to the side. Do you have those all good, all correct? Okay, so our learning focus for today then is going to be to write functions that are transformations and find efficient methods for graphing. So what do we see happening? What patterns can we notice? And how can we use that to help us to get through this? So let's start with one that we're pretty familiar with, taking a look at our y equals x squared, our favorite parent function here. In this lesson, you'll be writing equations and graphing functions that have more than one transformation. It's going to be a lot easier if you know the points really well on f of x equals x squared, so we can use them for comparison. We're going to call them anchor points. Okay, this is what we're going to be comparing to. How does this graph look? How can we compare it? That's the idea today. So we know this graph. We made a bunch of them yesterday. So anchor points. The vertex for this is at 0, 0. So that symmetry happens on the table at 0, 0. To get to the first point, right, 1, comma 1, we go over 1, up 1. And same way the other way, over 1, up 1 into the negative. And then positive. Over here, 2, 4. And negative 2, 4, right? We get that nice symmetry as we're looking side to side. 3, 9. And negative 3, 9. And we see that linear difference, right? First it goes up by 1, then by 3, then by 5, 7, 9, right? That we saw in the previous unit. And our line of symmetry, of course, is what splits it right in half. In this case, it's at x equals 0. It's our y-axis. It's going to cut right through the middle. Okay, so this is kind of our home base. Everything is going to be based off of this parent function. And let's see what we can figure out. Write the equation for each problem below. Use a second representation to check your equation. All right, so that's going to be the trial here. So here's the situation. It kind of not kind of, it definitely ties into what we looked at yesterday in terms of the idea of the area of a square. So let's take a look at this one and see what we think. The area of a square with side length x. Okay, so if we've got our side length x, that means this side is also x. But then the side length has been decreased by 3. Okay, so if the side length is decreased by 3, so now I have x minus 3. And then the area is multiplied by 2. Okay, well, if I want to move from this to the area of this one is x minus 3, that quantity squared. But now they're telling me that area is going to get multiplied by 2. All right, so I'm going to take 2 times that area. So 2 times the area here is going to be 2 times x minus 3, that quantity squared. Okay, so this is where I'm at now. And then 4 square units are added to the area. So then we're just going to take this and we're going to add 4 more to it. And so I think if we get all the way to the very bottom, the area of this square, the final area of this square, area is equal to 2 times x minus 3, that quantity squared, right? We had x, we took away 3 from the side length, we multiplied that by 2, and then we added 4 on the end. So we could make a table, but I feel like our drawing is also a decent representation of what that might look like. We could certainly make a graph out of that should we choose to, but I think that's kind of what we're looking for here. Okay, let's check out number 3 and see. So we can kind of follow through order of operations, right, as we look at that one. Checking out number 3, let's see what we notice. Actually, you know what? Let's go ahead and throw that on the graph Okay, go grab a graph piece. I'll put some out for you guys so you can make sure you grab one of these. Okay, so let's go ahead and get it on the graph and think about what that might be if we were to figure out what some of these things are. So if I have a side length of, I guess we're going to try to make a table. If we have a side length of 1, okay, let's think about what that might be. So if I put in 1 for x, negative 2 squared is 4, times 2 is 8, plus 4 is 12. If I go to 2, I've got negative 1 squared is 1, times 2 is 2, plus 4 is 6. If I do 3, that's 0, this is 0, we get 4. If I'm at 4, whoop, you can't see my table. Okay. If I'm at 4, 1 squared is 1, times 2 is 2, so 6. Oh, I think I see our symmetry happening. So I think 5 is going to be at 12. So let's see what this would look like on a graph. So over here, we've got 1, 12. I'm going to make it up here. We've got 2, 6. All right, we've got 3, 4. 2, 3, 4. And then we start to go back up. This one does seem to be pretty skinny, doesn't it? Okay, so we've got some shifting, right? We're definitely, compared to yesterday, right? If we think about our base equation, we're definitely over to the right, we're definitely up, and we're definitely skinny. I wonder where all those things are and how else they can connect to this. So what would you say is the vertex of this? The vertex of this is located at 3, 4. What would you say is the axis of symmetry for this one? X equals 3, okay? And it does seem to be, like, instead of over 1, up 1, we've gone over 1, up 2 for my vertex, right? As I'm starting to look. So it seems to be stretched out a little bit, maybe by a factor of 2. Okay, so just some things that we might want to note. I'll zoom in so you can kind of see what I wrote. Maybe I can. There we go. On that as well. Okay, so we might glue that in or tape it in or something just right there so we've got it. Okay, let's jump over to number 3 and do some exploring with this one and see what we notice and see what we think. So we've got just a graph. That's all we have. So we might want to look at some of these points. So I'm looking right here. 1, 2, 3, and down 1. So I'm at 3, negative 1. I'm looking at some other things. I'm noticing, we're kind of thinking about that relationship, right? Over 1, up 1. It seems to be a little more stretched out. I'm going over 1, up 2. So it seems to be maybe something by a factor of 2. So it seems to be over to the right. It seems to be down by 1. It seems to be stretched out just a little bit. Anyone have an idea on what equation they might want to put with this? Or do we want to try to put it into a table? Let's see what we've got if we put it into a table for this one. Let's see. So we've got x and y, and we've got 1, 7, and 2, 1, and 3, negative 1, 4, 1, 5, 7. Got that nice symmetry, right? Going around our vertex point there. I know some of you have an idea. So let's see what we think, right? We know it's been stretched by a factor of 2. That's going to influence my 2 out in front. It seems to be shifted over to the right. And so that's going to make this an x minus 3. And we also think it maybe has been shifted down. And so we're going to have a minus 1. So let's just make sure that works. Let's pick a point off of our here and see if it works. Let's put 5 in there. So 5 minus 3, 2. 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. Yeah, that equation seems to fit with our table. Okay. So we've got this, we've got our vertex in there by a factor of what's our axis of symmetry? X equals negative 3 is our axis of symmetry. Okay. So let's take a look at number 4. And in number 4, we've got a whole bunch of points. I wonder if putting those onto a graph might be helpful for us. So grab your second graph and let's see what we've got there. So we've got negative 4, 7, negative 3, 2, negative 2, negative 1. Okay, get all those graphed on there. Oh, we're coming back up. Here we go. There's our symmetry happening. So we've got something that looks like this in our parabola. So compared to our original, it seems to be shifted left and down. What do we think about the ratios? Are we kind of in the same distribution? Like from my vertex, I'm going over 1, up 1, going over 2, up 1, 2, 3, 4. That's our typical kind of ratio. So I don't think we've stretched it or compressed it. I think we've just shifted it around. So what might that look like in my equation? Y equals. So if I'm shifting it to the left, then I'm going to have an x plus, and how far left have I gone? Just one spot, I think. And then if I move it down, I know I'm going to end up having to take away 2. So what if we have something like this? Does that seem to match up with what we want? I think so. Okay, let's keep going and take a look at 5 and see what we think about this one. Okay, so another graph. Let's see what we can put together. So we've got this. I'm noticing it's upside down, right? So I'm thinking it probably has a negative a value at some point, right? Because we're opening downward. But this is at -3, 1, 2, 3, 4, -3, comma 4. Okay, we're opening down. Let's kind of see what we think about the stretch situation. So if I go to find another point, like this is kind of like halfway. Instead of being over 1, up 1, or just kind of that little distance, I'm only halfway. What if I go over 2? I'm only going up 2 instead of 4. So it seems like maybe it's been compressed. It's a little wider, maybe by a factor of half. So then how does that all fit in together? So we know all these different things, right? If we kind of think about it, I've got x, it seems to be shifted, right? So it seems shifted left 3. So if I'm going left, it's going to be like this. Did I do those other ones right? Did we do this right? Hopefully. Yeah, okay. Left 3. I know it's gone up 4, and it has a factor of 1/2, but it's also opening down. Boom. I think we can put that all together, and we see where all of these different pieces are coming from. So let's identify. We have our vertex, right? We have our axis of symmetry, x equals -3. We've got these different pieces going together. Okay. So that's kind of the first idea. Can we look at it? So now the idea is, can we go the other way? In 6, 7, and 8, can we take the information from this and be able to get it onto a graph just using this information? Let's check it out. Let's see. I think we can. So for this one, we're going to graph each equation without using technology. We're going to try to get the exact vertex and kind of identify where this is going to go and how this is going to look, at least 2 correct points on each one. So what do you notice about this? So it's going to open down. We know that because it's negative. So it could be all the reverse points, right? Instead of being 1, 1, it's going to be 1, -1, right? If the 3 wasn't there, right? 2, -4, that kind of thing. And then it's going to be shifted up 3. So nothing else is changing about this, right? This is going to be up 3 and it's going to be upside down. So let's think about if we can figure out what these points are. So instead of being at 0, 0, 0, 0 is where it would be if it was just this. It's going to be up 3 from there. 1, 2, 3. Instead of being at 1, -1, it's going to be up 3 from there. 1, 2, 3. Right? We've got that same ratio. Okay. Instead of being over at 2, -4, 1, 2, 3, 4, it's going to be up 3 from there. 1, 2, 3. And then to get my other points, I can just use that idea of symmetry on the other side. And we can even do one more. Instead of being at 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, -9, 1, 2, 3, we're going to back it up. And we're going to find that same point on the other side with our symmetry and get nice 5 points. There's 2 correct points on either side of the line of symmetry. Okay, so in this case, let's identify what is my vertex. My vertex here is at 0, 3, and my axis of symmetry is at x equals 0. And that didn't change. Fantastic. Okay, let's keep rolling and take a look over here at number 7. Let's break down all the different changes that we see. Okay, so I'm seeing this right here, right, +2. So that means in this case, it's going to have been moved to left, right? It's always that reverse we have to think about. And then this one is also 5 down. So every one of my points is going to be shifted 2 to the left and 5 down. So let's think about throwing this on the graph. Hopefully that'll work out. Okay, so instead of being at 0, 0, that's always my easy point to start with, I'm going to be 2 to the left of that and 5 down. 1, 2, 3, 4, 5. Okay. Instead of being at 1, 1, we're going to be 2 to the left of there, 1, 2, and 5 down, 1, 2, 3, 4, 5. And you can see that same ratio is right there. So I wonder if instead of having to count, do you know where the next point is going to be just based on how this is getting set up? Because we don't have any multiplier here stretching it or shrinking it. Yeah, I think it's going to be over 2 up 4. 1, 2, 3, 4. That ratio is still the same. Over 2 this way, up 2, 3, 4. Over 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The proportions of this are going to stay the same. And I think that if we take a look at this one, right, 3, 9 would have been 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. From there is this 2 left and 5 down. 1, 2, 3, 4, 5. Boom. Yeah, so we can use, if we're not multiplying it by anything, by a number or a fraction, by a whole number or a fraction, it's going to stay in the same proportion. That linear relationship is going to be the same. All right, so let's look at what our vertex is at. Our vertex in this case is at -2, -5. Hopefully you're starting to make some connections with this. Our axis of symmetry, our AOS, is going to be at x equals -2, right? Okay, let's keep rolling. We got one more. What things do we notice? Yeah, we have by a factor of 3. We seem to be moving 1 to the right and 2 up. Okay, so this is going to be, we think, probably real skinny. So let's see if we can go kind of low on this. Okay, so normally we would start at 0, 0. Okay, but we're going to go 1 right and 2 up. 1, 2. Okay. And so then how do we bring in this by a factor of? How are we going to try to create that? So if we can get our vertex in the right place, right, what do we do from there? So we can think if this was just a regular graph and it wasn't being multiplied, it would be over 1 up 1. But instead it's going to be over 1 up 3. 1, 2, 3. And instead of being over 2 up 4, 1, 2, 3, 4, it's going to be over 2 up 12. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Totally. And then we can find the ones that are their mirrors on the other side. Over 1 to here and over 2 up to here. And we can put that all together. So let's just test a point just to make sure we're not losing it. So if we put in a 3, right, 1, 2, 3, we're way up here at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're at 3, 14. Let's just make sure that works in our equation. So 3 minus 1 is 2. 2 squared is 4. 4 times 3 is 12, plus 2 is 14. So our equation is working. So this by a factor of changes how stretched out it is as we start to look at those ratios. All right, last couple of questions here. What point is the vertex? If this is my equation, what are you noticing? So take a second to flip back through. This one, we didn't even do this one. This vertex right here was at 1, 2. Right? This vertex was at -2, -5. This vertex was at 0, 3. This vertex was at -3, 4. Right? Are you picking up on a pattern here? So the point that is the vertex of the parabola is going to be located at h, k. You are absolutely right. All right, the equation of the line of symmetry, it always is connected, if you noticed, with this h value, right? Wherever we go to get to the vertex on the x-axis, that's where it's going to be. So x equals h. How can you tell if it opens up or down? Okay, if a is positive, your graph is going to be happy, right? Positive, happy graph. It's going to open up. Okay, if a is negative, negative Nelly right there. Okay, we've got it opening down, right? If it's negative, it's going to frown. Negative, it's going to open down. Okay, how do you identify the vertical stretch? And so the vertical stretch or compression is going to come from the a value, right? So the value of a. Okay, does it matter which order the transformations are done? I mean, of course it does, right? This is math. We know order matters in these situations. So what do we really want to think about doing? So the order that we want to think about it is going to be any horizontal transformations. We want to think about, in number 2, the reflection and the stretching or shrinking. if I can spell here, shrink, stretch or shrink, there we go. And then last but not least, we want to think about those vertical transformations. Oh, we get them all on there? Okay. Awesome. Okay, let's turn the page. It looks like we're ready for some takeaways. Here we go, vertex form of a quadratic equation. Let's see if we can pull this all together. So this is one of our first forms. We talked about standard form, but this one is our vertex form of our quadratic equation because, interestingly enough, not very creatively, it gives us the vertex. Okay, so let's check it out. So vertex form is written as f of x is equal to a times x minus h squared plus k. Do you need to memorize this? Yes. Okay, vertex is located at h comma k. The line of symmetry is x equals h. The vertical stretch is going to be by a factor of a. It opens upward if a is more than 0. It opens downward if a is less than 0. Okay, we've got 3 left that we are going to be working on just to make sure, and then we're going to do our retrieval briefly to make sure we're good to go. So quick graph method for graphing quadratics. What's the quick graph method? Well, it's kind of what we've been practicing just a moment ago. We're going to get going first off the bat with getting our vertex in place. Okay. And then we're going to pay attention to what is happening with this. Okay, and this one is going to be -4, -3, so I make sure we leave enough room for that. So instead of being at 0, 0, we're going to be at 4, -3. What am I saying to myself? My vertex here is where we're going to start with. So start with your vertex. Vertex is at +4, -3. 1, 2, 3, 4, 1, 2, 3. Okay, that's my vertex. Do I have any scale factor? Am I going to be having a factor of a of anything? Nope. Am I reflecting it in any way? Nope. And so what we're going to end up doing then is just giving it that regular old scale. So we don't have to put in a bunch of points and build a table. Can you put in a bunch of points and build a table? Yes. Do you have to do that? No. So we know it's going to be over 1, up 1, over 1, up 1, over 2, up 4, 2, 1, 2, 3, 4. Same thing over here. Over 3, up 9, 2, 3, 4, 5, 6, 7, 8, 9. And using your symmetry, you can get this graphed super, super quick, right? That's the quick graph method because we didn't have any kind of an a value, right? So it just has that standard equation and then using your symmetry. Okay, so let's check out this one. What can we do with this one? It has a little bit extra going on with it. First things first, we've got our vertex, and our vertex is going to be at -2, +5. So let's see if we can, and this is going to end up being negative, so just a little bit of space here like this maybe. Okay, so -2, +5, 1, 2, 3, 4, 5. There's my vertex. I know it's opening down. And so it's going to be kind of reversed, okay, from what a lot of the different points might be. It's not going to be changing as far as the scale, right? The distance between the points are going to be exactly the same. They're not being multiplied or by any number. So instead of being over 1, down 1, well, it is going to be over 1, down, not instead of anything. So over 1, down 1, right? Over 2, down 4. 1, 2, 3, 4. Over 3, 1, 2, 3, down 9. So it just keeps that kind of rigid shape, and all we're doing is it's sliding it around the graph and flipping it over, these transformations, right, that we talked about in Math 8. Okay, I think that's looking good. Awesome. And then we've got one more that we're going to try to do. The equation's down here, and then the graph is over here for whatever reason. So let's slide over here and let's rewrite our equation. So y equals 2, so by a factor of 2. And then we've got a little shift as well. So let's check out what we've got going on here. So it looks like we're going to have a vertex here at -1, -5. And we have a by a factor of 2. So that's going to stretch our graph out a little bit. Rather than being that 1 over 1 up 1 over 2 up 4, it's going to be stretched out a little bit. So, and it's opening up, but we're going to be at -1, -5. So we don't want to go too short on our y-axis here. Somewhere in here. Okay, so -1, -5, 1, 2, 3, 4, 5 is my vertex. It's opening up, right? And instead of being over 1, up 1, it's going to be over 1, up 2. Instead of being over 2 up 4, it's going to be over 2 up 8. 8, right? So instead of having this distance between, it's 2, right? Instead of 1, it's 2. And over here, instead of being 3, it's 1, 2, 3, 4, 5, 6, right? We're stretching the whole thing out. So we're going to end up with these symmetrical points. And then we can even do one more, right? So usually it's 1, 3, 5. Instead, it's going to be 2, 6, and then it's going to be 10, right, to the next point. So way up here, I think. Okay, and that's going to happen as well as if it was over 3 up 9, it's going to be over 3 up 18, right, which is the same effect. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, way, way, way up here. Okay, cool. So really skinny, really narrow graph with our vertex and our by our factor of. All right, vertex form is the name of the game today. We've got that. Let's take a peek at our retrieval, and then we'll get you guys working on your work time. All right, the standard form for a quadratic equation is here. Can you identify A, B, and C? I think you very well can. So A, B, don't forget the sign, and C. So 3, -7, and 12. For 2, what's A, B, C? 9, 4, -8. For 3, 2, 11, and 15. And for 4, -5, 41, and 36. Okay, using your table, can you identify the vertex, the equation for the line of symmetry, and state the number of x-intercepts the parabola will have, if any? State whether the vertex will be a minimum or maximum. Okay, so we're going to have to say, oh, they put it here for us. That's nice. Okay, checking it out. Do you see the symmetry? I know you do. So here we got our matching pairs. Okay, and so it looks like this is going to be my vertex right in the middle. Okay, 0, -7. That makes my line of symmetry x equals 0. So this is centered right around the x-axis. Does it have any x-intercepts? Is it ever going to touch 0? Let's kind of look. It seems to be starting at -7, and then the next point's at -6, and at -3, and at 2, and at 9. So it seems to be opening upward, and so I think we are going to have x-intercepts, and I think they're going to happen, right? It's when y is equal to 0, our x-intercepts. It seems like we would probably have something in here that would be between -3 and 2, right? And it would happen again in here. So I think we're going to have 2 x-intercepts. Okay, and then is this going to be a minimum or a maximum? Well, if it's opening upward, if this is our parabola, then I think, ooh, you can't see what I'm writing there. How about that? Then I think we're going to have a minimum value just right there. Okay, so let's check it out. And you're ready, identifying A's, B's, and C's. I think you're going to be okay with that. Now, here's the thing. It says the instructions are here, so just be careful. Multiply and write each product in this form, and then identify A, B, and C. So if you get to these and you're confused, it's because the directions are on the previous page. Okay, can you graph these? State the vertex, be precise, and graph at least 5 points. So using what we know about how it's moving around to be able to get it onto the graph is going to be the goal. Look back at your notes if you need to. And thinking about what kind of, where it's going to have intercepts. And then for the go, I think just using that symmetry, right? Which can you identify? If you need to graph it out, then do that. But I think you guys should be good to go with those. Excellent.